Alright guys, you know the drill. We got our warm up here, so go ahead and make sure the video is paused. When you're done going through the warm up problems, come back and check your answers. Okay, so again in 3.3 we're going to be doing some converses of some theorems. So that's what this warm up is kind of about, is making sure we're good at finding converses and things like that. So if you are good at that, then this should have been really easy. If not, well, we're going over it. So in this case, to get started, I will state the converse of each statement. So you have to first know what a converse is and how it's manipulated or how it's changed from a conditional statement. So I'm highlighting again the hypothesis and the conclusion. So in this case, this is my hypothesis and that is my conclusion. I'm just going to switch those around. So you would say if A plus C equals B plus C, then A equals B. Again, converse of a statement or a conditional, you take the hypothesis and conclusion and switch them around. Alright, number 2, using the same concept, take the hypothesis and conclusion and switch them. So I'm going to take these two statements and they're going to switch places. I'll do it out here so I have a little bit more room. So if angle A and angle B are complementary, then you can say that the measure of angle A plus the measure of angle B equals 90 degrees. Like I said, if you know converse statements, conditional statements, converses of conditional statements, this is pretty easy stuff right here. Last one, gonna wrap this up. We got an hypothesis and we got our conclusion. All right, I'm just highlighting those and we're gonna switch places again. So here we go. Just double check that you had all this. So if A, B, and C are collinear, then AB plus BC equals AC. Okay, so there's your warm-up. Again, you need to know what a converse is. That's kind of important for this lesson. So that's why, again, we want to make sure we go through this, we all understand what a converse is. Okay, so that will kind of lead us into what we're doing in 3.3. So our goal today, our objective, we're going to use angles formed by a transversal, the ones that we really learned about, all those postulates and theorems that we learned about in 3.2. We're going to kind of use those theorems, and we're going to actually use the converse of those theorems to prove lines parallel. If you remember in 3.2, so if we're in 3.2, we started if we had parallel lines, that's a symbol for parallel, then I had congruent angles. That was kind of where we were at in 3.2. If you had parallel lines, then we were able to use the transversals, things like that, to find congruent angles. Well, now we're going to switch those around. If we know, for example, that all interior angles are congruent, then I can state that the lines that are formed by the transversal are parallel. So again, that's our objective, to make sure we understand and are able to prove those theorems. So again, we already kind of talked about this. I'll just kind of read through it and move on to the next slide. So again, recall that the converse of a theorem is found by exchanging the hypothesis and conclusion. I mean, that's exactly what we did in the warm-up, so we should be good on that, right? The converse of a theorem is not automatically true. If it is true, it must be stated as a postulate or proved as a separate theorem. And again, that's, if we have a postulate and we want to go ahead and write its converse and it's still true and it makes sense, then we can say it's the converse of that postulate. So we can call it a postulate. If it's a theorem and we write the converse, then the converse would also be a theorem. We'll have to prove it. You'll see that as we go through these. Okay. Alright, so here's our first converse postulate and theorem. This one is going to be the converse of the corresponding angles postulate. So if you know the corresponding angles postulate, then you know the converse of it. it's the same postulate, we just switched, again, the hypothesis and the conclusion. So again, remember in 3.2, this was our conclusion. This was our hypothesis. So we said if m is parallel to n, then corresponding angles are congruent. But the converse switches that around, okay? That's hopefully easy enough to at least kind of see, and it makes sense if you know the corresponding angles postulate, you'll know it's converse. But you're going to have to understand the questions, and the way we're going to go through these are going to be backwards as well. So here's a quick example. So use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. In a way, I kind of, what this reminds me of is stuff like Jeopardy. If you ever watched Jeopardy, I watched it when I was like, I don't know, 12, 13. My mom would always watch it, and I'd watch it with her. I guess it's still on TV, but if you remember on that show, they give you the answers, and you have to answer with a question. So you always say, like, what is, New Guinea or something like that. That's kind of what we're doing here in a way, because again, everything's kind of backwards. In 3.2, we were trying to prove that measure of angle 1 equals measure of angle 3, or we were trying to solve for that. We were given that the lines are parallel. Now we're kind of going backwards. We're given that the lines are parallel, and using the corresponding angles postulate, we have to prove, or not prove, in this case just say show. It's the postulate, not a theorem. We just have to show that L is parallel to M. So here's how we do that. Very simple. We're not doing a proof, so I'm not going to write it out as a proof. But I look at these two angles, and I would say angle 1 and angle 3 are corresponding angles. Now, way back when, I'm going to do it again because this is a time where we need it. I'm going to remind you of this little statement that I used to do with the 3 dots. So if you don't remember what that means, it means therefore. Any logical statement, we're going to be using these 3 dots a lot. So angle 1 and 3 are corresponding. Therefore, L is parallel to M by the corresponding angles postulate. Again, we don't have to prove this. It's a postulate, so I can go ahead and use it now. So again, it's not saying prove, it's just saying show using that postulate. So I showed that they're parallel using the postulate. Okay, so there we go. And that's, again, example 1A. We only talked about one postulate so far, so that's the only thing we can use at this point. Alright, moving on. Same example as just example 1B. Okay, so now they're giving us angles, so measurements for angles. So in this case, we're going to solve it algebraically. We're answering the same question. We need to show that L and M are parallel. So this one we're going to do algebraically. Here, look, we have 5 and 7, which are corresponding. So if L and M are parallel, then we know that these angles have to be congruent. So the way we would test that out is we would say measure of angle 7, we're going to call it 4 times 13 plus 25. And I'm going to figure out what that equals. Again, 7 and 5, those measures should be equal. So that's what I'm checking to see. If they're not equal, then L and M aren't parallel. So here we're going to go 4 times 13. Again, think of that as 10 times 4, which is 40, and 3 times 4, which is 12. Doing some mental math here. Okay, so that would be 52 plus 25. So that's 52, 62, 72, 77 degrees. So measure of angle 7 is 77. Now we're going to come down and look at measure of angle 5. Do the same thing. So that's going to be 5x plus 12. I'm trying to get 77. So I'm going to go 5 times x, which is 13, plus 12. Let's see what we get. So again, this is one. I'm just going to go 10 times 5, which is 50. And then 3 times 5, which is 15. Again, that's 5 times 13. I just do it in 2 chunks. So that's going to be 65 plus 12, which is 75, 76, 77 degrees. Okay, so just like the last problem, now that I know that they're 77 degrees, the measure of angle 5 equals the measure of angle 7. and I would say there they are corresponding. Therefore, my 3 dots, L is parallel to M by the corresponding angles postulate. And circle that. So that one just takes an extra step because they didn't tell you that they're equal. You had to kind of show that with the information that you were given. Okay, but other than that, once you've shown that, it's the same process. Just have to show that they're equal and they're corresponding. Once you've done that, you can then say that they're parallel. The lines that are formed by the transversal are parallel, because that's what the postulate states. Okay. All right. So there's some other postulates and theorems here. Now this next one we're not going to hit too much because it's more of a construction postulate, but I want to put it in the notes so you know to write it down. We will use it when we, there is a section where we're going to be heavy on constructions. We haven't done a lot of them yet, but we're going to hit them a lot in a couple chapters. So any postulate that we come across, we are going to eventually use, so make sure we have this. So postulate 332 states, through a point P not on line L, so let's say I had line L, so point P, and this is a postulate, so it should make sense. There's exactly one line parallel to L. So if I try to draw a line parallel to L, there's only one that I can put on here. It has to be this line. There's no other line you can draw that won't touch this one. So again, this is it. And that's really all the postulate is stating. There's only one parallel line to it. Okay, so that's, again, we'll deal with some of that with constructions and things. But it kind of goes hand in hand with what we're doing here. I mean, there's only one parallel line or set of parallel lines through that point. So you're only going to have one answer, right? So anyway, that's one of the postulates. Again, we won't use that a ton. It is kind of common sense in a way, so that helps. But these are the ones we're going to need. So you need to know these really well. And again, this is just from 3.2. So obviously, if you still don't know these theorems from 3.2, now you hopefully notice that the questions that deal with those theorems are just gotten doubled up. So there's twice as many questions now because now we have 2 units that apply these theorems. So you kind of need to know it. Okay. So we got our converse of the alternate interior angle theorem. We got a converse of the alternate exterior angle theorem and the converse of the same side interior angle theorem. And again, it's the same as the theorems, the originals, except that it's all flipped. So that's important to know. All right. So if we know these theorems, then great. They are theorems, so they do need to be proven. We're not going to prove all 3. They are proved in similar manners, so I can prove one, and we should be fine. So here we go. We're going to get to that in just a second. So example 2a. So referring to the diagram, we're going to use the given information and the theorems that we've learned. So now we're going to use them. I will go back and prove all these theorems, or we'll prove at least one of them in the notes. But we're going to use the theorems that we've learned. So it's very similar to the one example we did earlier with the postulate. So we need to show that R is parallel to S. Notice it did not say proof. Okay, just show. So we're just going to write a statement like we did last time. Okay. So measure of angle 4 equals measure of angle 8. That's what you're given. So measure of angle 4, measure of angle 8. Notice, again, this is interior. Well, these are exterior. So if you look, we have, in this case, 2 exterior angles, and they are on opposite sides of the transversal. Okay, so if you're kind of looking over here, we have our alternate exterior angle theorem, says the exact same thing, right? If these angles are congruent, then we can say that the lines are parallel. So they're telling me the measures are equal, so I know that angle 4 is congruent to angle 8, and they're alternate exterior angles. Therefore, we got that information set up. I can say that R is parallel to S by the converse of the alternate exterior angle theorem. As I say that, I want to make sure I go back and check the ones I did earlier. Did I forget to do that? Yeah, I forgot to write the converse. So make sure we go back and switch that. I don't know what I was thinking. Converse. These are all converses. So if you look back at the examples we did earlier, we got converse of the converse of. I'll fix that again. I can get that by the. Oh yeah, no, I had it right. Converse of the corresponding. Actually, I can keep that last part. Alright, so that's good. So I have to fix that, converse of, because we're doing the converse of the corresponding angles postulate. And same thing here, by the converse of the corresponding angles postulate there as well. I just forgot to write those earlier, so if we can go back and fix that, that'd be awesome. So I don't have to redo the video, I don't want to do that. Okay, so we are here. Okay, so we got those hopefully fixed. And now we'll move on. Alright, so very similar to what we were doing before. Now we have different postulates. So here we have measure of angle 3, measure of angle 7. So let's circle those first, see what we're dealing with. So it looks like we have two interior angles, and they're on alternate sides of your transversal. So it looks like I'm going to be using the converse of the alternate interior angle theorem to prove the line's parallel. So before we do that, we need to be able to state that measure of angle 3 equals measure of angle 7, and then I can set them congruent and all that stuff. So let's do this. Measure of angle 3. Well, that's going to be 2 times x, which is 50, so that's 100. So I got 100 degrees. Measure of angle 7, well, that's going to be x plus 50, and x is 50, so 50 plus 50, which is also 100 degrees. So I know they're equal. So angle 3 is congruent to angle 7, and their alternate interior angles, therefore R is parallel to S. And I'll say by the converse, I'll say it right this time, the converse of the alternate interior angle theorem. That's a little bit better. You can say angle, but they are angles, are plural, so I'll probably keep it that way. Okay, so again, you can, it depends on, obviously, you need to look and see what the relationship the angles have so you know which theorem or postulate to use. That's why I check that first. I say, okay, 3 and 7, they're alternate interior, so I know I'm going to be using that theorem. I just got to show that the angles are equal, which means they're congruent. So again, when it says show, you have to show your work. That's kind of what that's saying here. Without the work and without the reasoning behind it, you're not showing why those are parallel. So you may be like, oh, I can just go ahead and just state the theorem. Well, no, you can't. You're not showing it if you don't show the work. You have to show that those are the same measure, which allows you to say that they're congruent. Without you doing this work and showing me, it's wrong. Okay, I want to make sure you're aware of that. If you skip these steps, you don't write what I'm writing, you're not showing me. It's like a semi-proof where you don't actually need to show all your reasonings. Like you don't have to write down what step you did to get here, but you still need to show me your work. So again, what I'm trying to say is when it says show, that means show your work. Okay. Now, we have to do a proof at this point. So this one we're going to do our statements and our reasons. Okay, so we're going to prove one of our theorems. So let's do this. Statements, reasons. So if you look at this one, we have angle 1 and 3. And we're trying, well, we have P is parallel to R. So let's kind of look at what we're given here. P is parallel to R. We'll talk about our plane here in a second. P is parallel to R, and angle 1 is congruent to angle 3, which is given. Again, just, whenever you do a proof, just write down the given statement, and then we'll figure out what the heck we're trying to do here. Okay, so our goal here, and let's label our figure so we can see what they're giving us. So I know 1 and 3 are congruent. And they're telling me, in this case, that L and, or they're not telling me that, they're trying to prove. We know that P and R, we know that those are parallel. So I can label that. I don't like them having those red arrows on the other ones. If you are drawing yours, I would get rid of that for now because we don't know that yet. We're trying to prove that. So I don't want to have that written there yet. I mean, that's what we're trying to prove. Okay? So this is all we really have at this point. So as you go through this, you should be able to just kind of look, this angle 2 has to have something to do with the way we're going to prove this, and here's how we'll do it. I'll do this in green so you can see this is stuff we'll be figuring out as we go. So if you look, I have P and R, those are parallel. Well, P and R, since these are parallel, I can then use the theorem for this line right here. This is a transversal. I can use one of my old theorems from 3.2. These are alternate interior angles. So I can state that those two angles are congruent. That's it. I'm able to do that because they said that P and R are parallel, therefore M is a transversal going through those. So your next step, again, when you say, what do you do once you write down your given statement? Well, you look at the figure, you look at the information, you say, well, what do I know? What's something else I can label? And that's something you can label. So you have to just look at the picture and figure it out. Yes, you're going to have to think and figure it out without somebody telling you exactly what to do. I'm sorry, that's how you're going to do it. So in this case, I can say that 3 and 2 are congruent. I can tell because they're alternate exterior. So I'm going to write that. Angle 1, not 1, sorry, angle 3. Angle 3 is congruent to angle 2, and that's by the alternate exterior angle theorem. That's from 3.2. Again, these are on the outside. Remember, you got your exterior. This is exterior from P and R, because I said those are parallel, and they're on alternate sides. This is on the left side of the transversal, this is on the right side. Alright, at this point now, see, I can cut out the middleman, and I can now say, you don't show that work, but I'll get rid of it. I can now say that angle 1 is congruent to angle 2. Again, I'm getting rid of the 3 in between. Again, that's the transitive property of congruence. Okay, so now that you know that angle 1 and 2 are congruent, then I can, that's one of our postulates. Those are corresponding angles. Since I know that they're congruent, I know that L and M are parallel. So I can say L is parallel to M, and that's by the converse of the corresponding angles postulate. Again, look, 1 and 2 are corresponding angles with L and M. Since they're corresponding angles and we've shown that they're congruent, the converse of the corresponding angles postulate is my reason for them saying now that they're parallel. Okay. So again, if we're doing proofs, as you do proofs, again, reason sheet. Keep track of these. We'll be using the same types of theorems and properties quite a bit. Okay? Alright, just kind of start wrapping up here. Got some, have some application problems, but they're really the same, honestly, as the non-application ones. So if you see this one, hopefully you kind of see what I mean by this. So if you look, these two angles, they're same side interior. Now again, we got a small angle and a big angle. So if you remember from 3.2, if these lines, or these 2x4s, are going to be parallel, then these must have a sum of 180, right? So we're just going to use the converse of the same side interior angle theorem. So when they're giving us our angles, angle 1, angle 2, if x is 15, show that they're parallel, we have to show that these are supplementary. That's our goal. Again, if these are supplementary, then I can state that these lines, or these pieces of 2x4s, are then parallel. So it's just like what we were doing earlier, except now we're not trying to show that they're equal, we're trying to show that they're supplementary. So here we go. The measure of angle 1 equals 8 times 15 plus 20. So again, I'm going to multiply this out. Think 10 times 8 and 5 times 8. Oops. So that's 80. That's 40. Add them up. That's 120. So the measure of angle 1 equals 120. Now I have measure of angle 2. That equals 2 times 15 plus 10. So that's going to be equal to, well, again, we'll do 10 times 2, so 20, and we'll do 5 times 2, which is 10, so 30. So I have the measure of angle 2. Actually, I did that wrong, didn't I? No, I didn't. Measure of angle 2 equals 30 plus 10, which is 40. Okay, so what your goal is in this problem, again, a carver's creating a woodwork pattern and wants 2 long pieces to be parallel. The measure of angle 1 is 8x plus 20, and again, measure of angle 2 is 2x plus 10. If x equals 15, show that the pieces A and B are parallel. So again, what I've done at this point is I plugged in 15 into measure of angle 1, so I went 8 times 15, and that gave me 80. And actually, that's probably going to give me an issue because I forgot to add the 20, didn't I? So that's not really 120. I mean, 8 times 15 is 120. It's 80 and 40. So I'll go ahead and, there we go. I'll go ahead and fix that. So we have 120, and then this is 120 right here, the 8 times 15, plus 20. That's going to give me 140. That's better. Alright, yeah, those are going to add up now. That's probably a good idea. And then I plugged in the 15 for x on the second equation, 2 times 15. That gives me 30. Add the 10, and you get 40. So now I can say that 140 plus 40 equals 180. So again, because the measure of angle 1 plus the measure of angle 2 equals 180, and they're same side interior angles. And that's what I'm using because, so I don't need to say therefore, because of this. Let's see, pieces A and B are parallel by the same side, I'll do same side interior angles converse theorem. Again, you can, I'm just trying to show there's other ways you can word this, so I use because this time. As long as you make the statement in its proper English, we should be okay. Alright, so again, we had to show that the angles were supplementary. If you show that, then you're going to be fine. It's not a true proof, so you don't need to do all your reasons and statements and reasons, things like that. You do need to show your work. That is part of the answering the problem. Alright, so we got our lesson quiz for this unit, so make sure you go through that lesson quiz. There's 2 parts, so make sure you pause that and do these problems. And again, here notice again it says name the postulator theorems. We're not showing, it's not a name it. So that is the difference. If it just says name, I don't need all the steps. Just give me the theorem or the postulate that you'd be using. Okay? And then next up, use the theorems and given information to prove. So again, this one, number 5, is going to be an actual proof. I want to make sure you know how to do the proofs. And then at the end of the lesson, just do your reflections and you'll be all set.